Okay, good afternoon, class. How are you? Yung UVLE is still down, ano? So, madaming nagtatanong anong mangyayari. Well, obviously we'll have to extend the deadline for quiz 1. I cannot tell you now until when that deadline will be extended because I have no idea when UVLE will be live again. No? But it will depend on when UVLE goes live. Okay. But there's no extension to the problem set. The problem set has to be submitted at the deadline. Okay, so before I start with the lecture for today, are there any questions that you would like me to answer? Anything you want clarified before we move on? Anything? There's a question here. Saan po namin pwede ma-access yung course material? Hindi, as far as I know, ang pinrovide lang na course material is the lecture slides. Hindi ba nyo na-download yung lecture slides? If you don't have a copy of the lecture slides, send me an email and I can provide you a copy of the lecture slides. Any other questions? Gusto ba yung ano, no? Since you're already here, gusto nyo bang balikan natin ng sandali yung last example last time because we went through that very quickly? Do you want me to go through it again?
Sir, hello po.
Sir, go ahead. Yes,
may tanong po ako sa last lesson.
Okay.
Sa slide 11 ho.
Slide 11.
Yung page 11, I mean.
Sige, I'll share it, no? Page 11. Ito?
Po.
Okay. Ano yung tanong mo?
Wait lang. Sinulat ko to kahapon eh. wait lang. Wait lang sir i-figure out ko lang ulit. Yung sa ano po, sa C.
Sa C, okay.
Paano po naging valid yun?
Valid siya kasi, it is valid as long as it will follow KCL and KVL eh. No? So okay. yun lang yung condition. But as long as it does not contradict KCL or it does not contradict KVL, it is valid, no? For example, valid ito kasi pag nag-KVL ako clockwise, I'm going to get minus 10 plus 10 is equal to 0. So it doesn't contradict KVL, no? Ito valid ito kasi kung mag-KCL ako rito, I'm going to get minus 5 plus 5 is equal to 0, no? Ito hindi ito valid. Bakit ito hindi valid, no? Pag nag-KVL ako rito, okay? Hindi lumalabas yung ano. Yan, pag nag-KVL ako rito clockwise, I'm going to get minus 10 plus 5 is equal to 0. Pero teka, ano yan? No? That's a contradiction. No? Okay?
Okay po.
Okay, dito, let's say mag-KVL ako rito. Mag-KVL ako rito. KVL. What is my KVL equation? I'm going to get minus 10. Tapos na ba yun? Hindi pa, no?
Diba ho?
Plus, my
Plus
voltage
voltage
across
sa
the 5 ampere source is equal to 0. Now, all this is saying is I can compute for my voltage across the 5 ampere source, no? All this says is my voltage across the 5 ampere source is 10 volts. So far, there's no contradiction. Let's say mag-KCL ako rito. Mag-KCL ako dyan. Okay, what is my KCL equation? I have a voltage here. I have a current here dito sa 10 volt, no? So minus I, 10 volt, plus 5 is equal to 0. There's no contradiction there, no? It's just, all this is saying is the current in my 10 volt source is just equal to 5 amperes, but there's no contradiction. So this will not contradict KVL and it will not contradict KCL, and therefore it's a valid circuit. It is only invalid if it contradicts KVL or contradicts KCL.
Okay po. Thank you po, sir.
Okay.
At tapos ask ko lang rin po if yung pag kunyari current independent source, may voltage po ba siya?
Of course.
Pero po saan po siya naglalay? Independent po.
Current independent, sorry.
Po. Independent source, current independent source.
Yeah. There's a current, any element, any element, you have a current flowing through it and you have a voltage across it. That's true for any element.
Kasi po sa nung inaaral ko po yung sa first week.
Okay.
Yung sa independent sources ho. Is yung wait lang hinahanap ko, sir. Yung ideal daw na wait lang. Yung voltage po is across the load. Dependent sa load.
Yes. That's
depende
right.
ba siya sa ibang, kunyari may resistor ka nakatabi, magdedepende ba siya doon sa resistor na yon?
Okay. If you have a current source, ang current dito is always equal to I.
Apo.
Okay? Pero yung voltage, hindi mo alam kung ano yung voltage.
Apo.
Magdedepende yan kung ano nakabit dito. So just like you said, let's say this is a resistor. No? Let's say this is a resistor. Ang magiging value ng V is equal to IR.
Okay.
Kasi ito yung I, di ba? Your current will flow this way. So the value of V will be equal to IR. So the bigger your resistor, the bigger the voltage.
Okay. So pag dalawa po siya, sir, parang isi-series ko lang ho. Dalawang resistors po sa isang current source.
So parang ganito?
Apo.
Dalawa?
Ganyan. Apo.
Yes, R1, R2.
Ano ko lang.
So itong V is equal to I times R1 plus R2.
Pero we wouldn't mind po sa, kasi naka-distribute na pala dun sa, never mind the second question po. Sige, sir. Thank you po, sir. Thank you po.
Okay.
Okay po. Thank you po.
Any other questions? Ito yung sinasabi ko, no? I was willing to go back to this problem if you wanted. Kasi medyo mabilis natin kinuha last time. Are you interested in excuse me. Are you interested in going through it one more time? Itong problem na to. Okay? Actually, this problem already came out sa week 1, sa week 1, it was an example. Dun sa week 1, the way that this was solved was applying KVL in this loop to be able to get V, and then applying KCL in this node to get the current flowing through your 10K resistor, which will eventually allow you to get the value of V out. So dun sa week 1, this was solved using KCL and KVL. So dito sa week 2, the intent is for you to solve this using voltage division and current division. Now, what is this circuit? This is the circuit of a transistor amplifier. Hindi pa nyo kinukuha yung transistor, you're going to take that up in this course. But suffice it to say that this is the model of your transistor when it is operating in what we call the active region. Ito yung model ng transistor mo. So this is your input, and then this is your load. Now this circuit only works when your input is time varying. This only works when the signals are time varying. In other words, hindi ito gagana pag DC. Pag DC itong mga signals mo, itong mga inputs mo. That's why when we talk about this circuit, we can only talk about the effective value of the source voltage, which is, we talk about the term effective value. Yung effective value, pag-aaralan pa nyo yan when we study, we will study that when we study AC circuits toward the second half of the course. But for now, you just imagine effective value to be almost like a DC value. Imagine lang nyo, effective value, parang DC value din yan. Okay. So how do you solve this problem? First part of the problem, I'm supposed to solve for this voltage, because only after solving for this voltage will I be able to get the current flowing through here. So how do I solve for V? I solve for V using voltage divider. V is equal to VI multiplied by 2K all over 2K plus 500 ohms. So this is voltage divider. So V is equal to 2 millivolts times 2000 over 2500, and I'm going to get 1.6 millivolts. Let me just check. Yeah, 1.6 millivolts. So kung alam ko na yung V, ito alam ko na, madali ko na makukuha tong current na to. Let me call this I. What is the value of I? I is just equal to GM multiplied by V. GM is 30 milliamperes per volt. So this is 30 milliamperes per volt multiplied by 1.6 millivolt. I'm going to get 48 microamperes. So this is 48 microamperes. Okay. Anong nangyayari dito sa current na yan, Itong I na to. Yan, hindi pwedeng dumaan dito. Here, there is no current flowing. In other words, habang bumababa dito yung I, hindi siya pwedeng kumaliwa rito. Bakit? Kasi wala siyang babalikan, If a current is flowing here, it has to be able to get back to the source somehow. So if it's flowing here, it has to be able to get back to the source. But wala siyang babalikan. That's why there is no current flowing here. So all of this current I will be divided into these two resistors. Let's call this I1 and let's call this I2. Dito walang dadaan dyan. So now here, we can use current division. So using current divider, and then for the special case of two resistances in parallel, I have I2 is equal to I multiplied by 75K divided by 75K plus 10K. And I know that I is 1.6. Sorry, not 1.6. I is 48 microamperes. So what will I2 be equal to? Okay, I will be equal to I will be equal to 42.35 microamperes. Okay. So itong current na to will divide between this and this, and I2 will be equal to 42.35 microamperes. So finally, ano yung magiging value ng V sub O? V sub O, now notice, no? The direction of the current I2 is going up, but the polarity of the voltage is going down. So this is opposite the passive sign convention. Therefore, V sub O must be negative. No? V sub O will be negative of I2 times 10K. So I'm going to get 423.5 minus 423.5 millivolts. So this is my answer. Okay, so ang input ko is 2 millivolts. Ang output ko is minus 423.5 millivolts. So you have a gain. The magnitude of the gain is 423.5 over 2, which is about 211. That is the magnitude of the gain. Your gain is negative. Because your output is negative, your input is positive. Ano ibig sabihin ng negative na yan? Ano? Remember, I said, these are time-varying quantities. So, yung signal mo is time-varying. Yung input mo, tumataas, yung output mo bumababa. So, pag ganyan siya. No? Okay, that's what we call they are out of phase. Hindi siya sabay na ganyan. Kung negative yung output mo, ibig sabihin pag ganyan siya. And then yung isa maliit, yung output mo malaki. So parang pag ganyan siya. So that's how you can visualize what's happening here. No? And that's what negative gain is. No? So that's all I want to say at this point about this problem. No? Because like I said, a lot of the concepts will still be introduced yet to you. But the point is you can solve this using voltage division and current division. Okay? Any questions with regard to this? So you can see now why it is called an amplifier. Because it amplifies. Yung 2 millivolts, in-amplify niya 211 times. Okay, we can now go to the lesson for today. So just to recap, marunong na kayo ng circuit simplification. When do you use circuit simplification? You use it when there are few unknowns in your circuit. So what you do is you simplify part of the circuit para mas madali yung computation natin. So far, we've only learned how to simplify purely resistive networks and sources in parallel and sources in series. That's what we've learned to simplify. Now, one thing about, and I also discussed this in the other class, one thing about resistive circuit simplification, there are times when you're not going to find elements that are either in parallel or in series. Now, I'm going to give you an example. Let's say this circuit, A, B. Okay, obviously, these two are in series. And then these two in series are in parallel with this. And finally, the equivalent circuit of this is in series with this. No? Now, what will happen if I put another resistor here? Can you find any two resistors that are in series? Let's say this is R1, R2, R3, R4, R5. Can you identify two resistors in series? Anyone? Meron ba naka-series? Wala, no? Tama yung I got the correct answers from David Gan and Morey Piatos. Wala, no? There are no two resistors in series. In the same way, there are no two resistors that are in parallel. You might be tempted to say, for example, you might be tempted to say R1 is in parallel with R2. But for R1 to be in parallel with R2, this point should be connected to this point, and they are not. No? So R1 is not in parallel with R2. And then you can see that nothing here is in series, because if it is in series, meaning to say at the point that they are connected, there is nothing else that is connected. No? So wala dito naka-series. Does that mean there is no equivalent resistance between A and B? Of course not. There will always be an equivalent resistance between A and B. Okay? The point is, at this point, hindi pa nyo alam how to do it. But you're going to learn how to do it later on. No? So we don't want to complicate things for you now. We're limiting simplification to parallel and series combination. But there are other transformations that you will learn later on that will allow you to get the equivalent circuit between A and B. Okay, so you know now how to simplify parallel and series combinations. You know how to simplify sources in series, sources in parallel, and you know how to use voltage division, and you know how to use current division. So we're now going to go to some circuit analysis techniques. First of all, where am I headed to here? No, we're going to go through a more structured way of solving for the unknowns in a circuit. First of all, we're going to discuss terms used to describe circuits. And then we're going to go into circuit analysis using KCL and KVL. And then I'm going to introduce nodal analysis. So first, terms used to describe circuits. And some of this have already been introduced to you. Or some of this you already know the meaning of by context. So yung node, alam na nyo yung node, no? This is the point where two or more elements connect. Now, essential node, this is a node where three or more elements connect. Okay. Ano ang significance ng essential node? The elements that are connected to an essential node are not in series. Because this is a point where three or more elements connect. So yung mga elements na nakakabit sa isang essential node cannot be in series. A path is a trace of adjoining elements with no elements included more than once. So I have elements that are next to each other. Okay, a path is a trace of adjoining elements, but no element should be included more than once. And a branch is a path that connects two nodes. So any element that connects two nodes is considered a branch. Kung meron tayong tinatawag na essential node, meron din tayong tinatawag na essential branch. An essential branch is a path that connects two essential nodes without passing through an essential node. Finally, we have a loop. A loop is a path whose last node is the same as the starting node. So we already introduced the term loop when we discussed Kirchhoff's voltage law, because you always apply Kirchhoff's voltage law along a loop. That's a path whose last node is the same as the starting node. And then a mesh is a loop that does not enclose any other loops. That's all going to be clearer in this example. Okay. Identify all nodes. A node is a point where two or more elements connect. So I already have labeled the nodes here. The nodes are A. This is the point where V1 and R1 connect. And then B is the point where R1, R5, R7, and I connect. E is where R5, R3, and R6 connect. So I already labeled all of the nodes. You have A, B, C, D, E, F, and G. Is this a node? Is this a node? Yes or no? Can I hear some answers? Yes, it is a node. No? Yes, but it is the same as node B. It's the same as node B. It is a node, but it's the same node as node B. So actually, if you take a look at node B, itong buong to, this is actually node B. Where you have R1, R5, R7, and I connected. That's all node B. The same thing here. This is really your node G. This is your entire node G. And this is your node B. So again, remember what I told you last time, in circuit topology. You can compress a wire into a single point, or you can stretch a wire out, and it will act like the two circuits will act exactly the same. So anyway, your nodes are A, B, C, D, E, F, and G. Okay, identify all essential nodes. So can you answer me, what are the essential nodes here in this particular circuit? So I got an answer. A, B, F, and G. B, E, C, and G. B, E, C, B, E, G, B, E, C, G. Sari-sari mga answers, no? Essential nodes. Sige, let's go through. Let's go through each one, no? Each one. Is A an essential node? No, it's not. Right? Remember, ang definition natin ng essential node, dapat 3 or more elements connect, no? So A obviously is not an essential node, no? B, yes, is an essential node. B, E, C, G. So si Patrick tama, no? B, E, C, G. Si David tama, B, E, C, G. Si Nuremberg, B, E, G. Nakalimutan niya yung C. All the rest got BECG. So more or less tama, no? So there are only 4 essential nodes: B, C, E, and G. B, C, E, and G. Okay. Identify all branches. Identify all branches. How do you define a branch? A branch is a path that connects 2 nodes. So ganito na lang tanong ko. How many branches are there in this circuit? Can somebody answer? Any other answers? Okay, I already got the correct answer. No? How many branches are there in this circuit? Actually, lumalabas, each component here is a branch. Right? This component is a branch that connects C and A. This component is a branch that connects A and B. So if you want to know how many branches there are here, they are equal to the number of components. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 branches. No? So may tamang sagot, ano? May nagsabing 10. Okay. So these are all the branches: V1, V2, R1, R2, R3, R4, R5, R6, R7, and I. Those are all your branches. So next question. What are the essential branches? How many? First of all, how many essential branches are there? An essential branch, by definition, is a path that connects 2 essential nodes without passing through any essential node. A path that connects 2 essential nodes without passing through any essential node. So how many essential branches are there? No one? I got an answer of 4. Unfortunately, there are more than 4. No. I got an answer of 6. Unfortunately, there are more than 6. Okay. These are your essential branches. Asan yung mga essential branches natin? This is one essential branch. Isa yan, no? R2, R3, this is another one. V2, R4, this is another one. So tatlo na yan, no? This connects 2 essential nodes without passing through any essential node. Then what are the others? So that's 3, this is 4, 5, 6, and 7. So siguro yung iba nakalimutan yung I. Okay? So there are 7. There are 7 essential branches. Okay, you're going to find out later on, well, actually I can mention it now, that the number of essential branches are also the number of branch currents in a circuit. No? The number of essential branches is equal to the number of currents in a circuit. Kasi dito, isang current lang yung dumadaan dito. No? Remember that when you have a non-essential node, then the current entering will be equal to the current leaving, and therefore you only have one current flowing here. No? You will also have one current flowing here. You also have one current that is flowing here. Dito, may current ka rito, current dito, may current ka rito, and finally may current ka dito. So you actually have 1, 2, 3, 4, 5, 6, 7 currents flowing in this circuit. Okay. Okay, can someone, in terms of nodes, in terms of the nodes that you see here, can someone give me an example of a loop? Can someone give me an example of a loop? Okay, I have somebody answered A, B, E, D, C. No? A, B, E, D, C. Ibalik mo yung A, no? Because it has to go back to where it started from. So A, B, C, E, D, C, A. No? So that's a loop. That's an example of a loop. Okay. So actually, there are so many loops in this particular circuit. I'll show you three. No? This is one loop, yung A, B, C, D, C, A, B, E, D, C, A. That's one loop. And usually, we specify it in the direction we are traversing the loop when we do KVL. No? This is another loop. And then this whole thing is yet another loop. As a matter of fact, how many loops are there? Anyone want to venture a guess? How many loops are there? How many possible loops are there in this circuit? Okay, so I get an answer 4, I got an answer 7. Actually, there are much more than 7. Para ito yung mga trick questions sa mga, I got 10. Actually, I think I counted 12. No, I can't remember, but I think I counted 12. But anyway, you can just do this on your own. No? Figure out how many loops there are in this particular circuit. Ito, iba to. Identify all the meshes. How many meshes are there? Okay, this one is right. There are only 4 meshes. No? Sabi ni Nuremberg, there are only 4 meshes. Ano yung meshes natin dito? Ito yung 4 na meshes. What is a mesh? A mesh is a loop that does not contain any loop within it. A loop that does not contain any loop within it. Hindi ito mesh. This is not a mesh. A, B, E, G, F, C, A. This is not a mesh. Because within this mesh, I have 2 loops. I have this loop and I have this loop. No? This is also not a mesh. Because within this mesh, I have 2 loops. Lalo na hindi ito mesh. Because within that mesh, I have 10, I said 12 loops. No? So a mesh is a loop with no loops within it. No? Now, if the circuit is planar, first of all, let me define a planar circuit. No? A planar circuit, this can be drawn without wires crossing each other. Yun yung definition ng planar circuit. A planar circuit is a circuit that can be drawn without wires crossing each other. For planar circuits, the number of meshes is equal to the number of what we call window panes. The number of meshes is equal to the number of window panes. Imagine this to be a window, and imagine this to be your window panes. So pag tinignan mo yung circuit, imagine yung bintana siya, and then each square is a window pane. The number of meshes is equal to the number of window panes. But that's only true for planar circuits. Anyway, lucky you, most of the circuits that we will be dealing with are planar circuits. So there are exactly 4 meshes in this particular circuit. Okay, now let's go to circuit analysis using KCL and KVL. How many simultaneous equations must we solve? The number of unknown currents in a circuit are equal to is equal to the number of essential branches B whose currents are not known. The number of unknown currents in a circuit is equal to the number of essential branches B whose currents are not known. So we need, if we want to solve for all of these currents, we need to form B independent equations involving the B unknowns. If the circuit has n essential nodes, we can form n-1 independent KCL equations. You remember when we discussed a single node circuit? So that was taken up in week 1. So this is an example of a single node circuit. Okay. Actually, there are 2 nodes here. No? This is one node, and then this is the other node. No? Now let's say this is I. This is I1, I2, and I3. If I do a KCL here, what is my KCL equation here? I get minus I is plus I1 plus I2 plus I3 is equal to 0. If I do a KCL here, I'm going to get I minus I1 minus I2 minus I3 is equal to 0. So these are the same. Meaning to say they are not independent. They are not independent equations. So in general, the case is if you have n essential nodes, so dito you actually have 2 essential nodes, you can only form n-1 KCL equation. So here, you can only form 1 KCL equation because your other KCL equation will be exactly the same. And that's true in general. For example, if I have, sabihin natin, I have 3 nodes. No? So let's say I have 3 nodes. So how many currents do I have now? Let's say I have I1, I2, I3, I4. So this is A, B, and let's say this is C. If I do a KCL for A, KCL for B, and I combine, I will get the KCL for C. And you can try that as an exercise. No? Try as an exercise. Try doing a KCL for A, doing a KCL for B, and combining the two, and you're going to get the KCL for C. So that's just this. No? If you have n essential nodes, in this case 3, you can only form 2 KCL equations, n-1 KCL equations. Now, I have B unknowns. I have B unknown currents. I can form only n-1 KCL equations. Saan ko kukunin yung the rest of the equations that I need? No? Saan manggagaling yon? So this is the remaining equations that I need. I need an additional b minus n minus 1. And I do that using my KVL equations. Okay. I do that using my KVL equations. The KVL equations, we usually use the meshes. When I form my KVL equation, I usually will use the meshes. Why? No? Why will I use the meshes? Shift here. No? Let's say I have let's say I have this. No? I have this circuit. Sorry. Let's just say I have this. Let's say this is A, B, C, D, E, F. No? If I do a KVL for A, B, F, C and a KVL for F, C, D, E. So A, B, F, C, A. And then I do a KVL for F, C, D, E, F. No? So ito yung isang KVL ko. Sorry. This is the problem with my tool. Nabubura siya, no? So again, no? A, B, C, D, E, F, no? So I do a KVL for A, B, C, F, A, and then a KVL for C, D, E, F, C. No? So this is one KVL, and then another KVL. If I combine these two equations, I'm going to get the KVL for A, B, C, D, E, F, A. No? In fact, if I do a KVL for this, and I do a KVL for this, what I'm going to get, if I combine the two, is the KVL for this whole thing. Meaning to say, these three are not independent. They are not independent because the KVL for this can be derived from the KVL for this too. So I can form three KVL equations here. I can form this KVL, I can form this KVL, I can form this KVL, but the three are not independent. Okay, so that your equations are always independent, we usually apply KVL to the meshes. So in practice, because if you apply KVL to the meshes, then you are sure you will always get a set of independent equations. Okay, so let's consider the previous example. So I assume that my known quantities, the known, yung alam ko, are the resistance values and the independent sources. So I know this. These are all my known quantities. What do I not know? What I don't know are the currents in my essential branches. So I have 7 essential branches. I have 6 essential branches that have unknown currents. So pag tinignan mo yung 7 essential branches, itong current na to, alam ko na yung value nitong I na to. So hindi na unknown yan, no? So the only currents that I don't know are the ones in the other essential branches. Here, 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 and so forth. No? So I have 6 essential branches with unknown currents. I need 6 simultaneous equations to solve for all 6 currents. Now, how many essential nodes do I have? I have 4 essential nodes. No? B, C, E, and G. 4 essential nodes, apat, I can only form 3 independent KCL equations. So 6 unknowns, 3 KCL equations. Saan ko kukunin yung 3 pang equation na kailangan ko? The 3 equations that I need, I can form by applying KVL to the available meshes. Okay, so let's do that. These are my 6 unknown currents. I have labeled them I1, I2, I4, I5, I6, and I7. Lahat nitong mga pulang arrow are my unknown currents. I1, I2, I4, I5, I6, and I7. Ito, alam ko na, no? So those are my 6 unknowns. I can only form 3 KCL equations. So let's form our KCL equations. No? So let's start with node B. Ano yung KCL for node B? Okay, remember our convention. The usual convention, if it is leaving the node, it is positive. If it is entering the node, it is negative. No? So KCL for node B, this is minus I1, okay, plus I5, plus I7, minus I is equal to 0. No? Ito yung I1 pumapasok, I5 lumalabas, I7 lumalabas, I pumapasok, equal to 0. So that's the first. Minus I1, I5, I7 minus I equal to 0. For node C, I have 3 elements connected to node C. I have my V1, V2, and R2. No? So node C, I just have I1, it's leaving the node, I2, it's leaving the node, and I4, which is entering the node, no? That's equal to 0. And finally, for node E, you get minus I5, papasok, minus I2, okay, papasok din, I6 palabas is equal to 0. Okay. So those are 3 equations that I need. Remember, I have 6 unknowns, 6 unknown currents. I can write 3 KCL equations. In this particular case, itong node G, I chose this to be my reference node. No? The node G I chose to be my reference node. If I try to write KCL for node G, I could have derived that by combining these 3 equations. Okay, just some points that I want to make. First, how do we know the direction of the currents? We can assume. We can assume the direction of the currents. Usually, we base it on the power supplies. Because, for example, usually, ang usual case, if this is supplying energy, then your current will be flowing out of the positive terminal. No? So usually, you base it on the power supplies. But there's nothing wrong with assuming the opposite direction. Kung mali yung assumption mo, nag-compute ka, lalabas negative yung value. Yun lang yung mangyayari. So you can assume current directions. And then I already mentioned this. The KCL equations for node G can be derived from 1, 2, and 3 by eliminating I1, I2, and I5. Thus, it is not dependent. That's why ito tinawag natin na reference node. No? Okay, again, 6 unknowns, I already have 3 equations. So saan ko kukunin yung remaining equations? I do that by applying KVL to the meshes of the circuit. I have 4 meshes. Okay, how many KVL equations can I form? How many independent KVL equations can I form? I can form 4 KVL equations because I have 4 meshes. But I only need 3. No? I only need 3. Okay, let's show. For mesh 1, no? This is mesh 1. What is my KVL equation? I go around mesh 1, let's say in the clockwise manner. So you always have to decide what direction you want to go around the mesh. No? Let's say I want to go around mesh 1 in the clockwise manner. I'm going from negative to positive. So that is minus V1. Okay, here, R1, my current is flowing from left to right. My current is flowing from left to right, meaning to say the polarity of my voltage will be this polarity because my current is from left to right. Right? So if I'm going clockwise, it's going to be a voltage drop. Okay, so that's plus VR1. But what is VR1? VR1 is equal to I1 times R1. Okay. Here, I'm going down. Again, it's going to be a voltage drop. This is going to be plus I5 times R5. Okay, take a look here, no? Here. The direction of current is from left to right. Therefore, VR3 will have this polarity. But I am going around my mesh in the clockwise direction. So I'm going from negative to positive. So that's going to be minus VR3. No? It's going to be minus I2 times R3. And finally, minus I2 times R2, this is equal to 0. So that's the KVL for mesh 1. So it should be exactly the same. If I do the KVL for mesh 2, this is what I'm going to get. Now, I need one more equation. I have 2 more meshes. This mesh and this mesh. So let's say this is mesh 3, and let's say this is mesh 4. Saan ako magke-KVL? Sa mesh 3 or sa mesh 4? Can I hear answers? Will I do a KVL on mesh 3 or on mesh 4? Okay, some people are answering any. Some people are saying mesh 3. Walang sumagot ng mesh 4. Subukan natin mag-KVL sa mesh 4. No? So this is mesh 4. So let's try to do a KVL here. Okay, going in the clockwise direction. So I'm going to get, okay, going in the clockwise direction, I'm going to get minus I7 R7. Okay. Tapos na ba yung KVL ko? Hindi pa, no? Plus, I will have a voltage source here, no? Or rather, I will have a voltage across my current source. So I have a voltage here. Let's call this VI, no? So plus VI is equal to 0. Where VI is the voltage across the current source. The problem is, this is a new unknown. That is a new unknown. In other words, if I do a KVL here, I will be introducing a 7th unknown. I have 6 unknowns right now. I will be introducing a 7th unknown. But I only want to solve 6 equations in 6 unknowns. I want to avoid having to form a 7th equation because I would have more simultaneous equations to solve. So it is not a good idea. No? This is a bad idea. Better to perform a KVL here. Because if I perform a KVL here, I do not introduce any new unknowns. So the KVL for mesh 3 is this. Okay. So now I have 6 equations in 6 unknowns. Okay. I mentioned this earlier, applying KVL on the meshes will ensure a set of independent KVL equations. And KVL is not applied to mesh 4 because we do not have an expression for the voltage across the current source I. So we don't want to introduce a new unknown. So 6 equations, 6 unknowns, that is no longer an EE problem, that's already a math problem. You learned how to solve such problems in your algebra even as early as high school, junior high, baka junior high, marunong na kayo niyan. So that's not my problem. Okay? In fact, use your calculator. Hanggang ilang unknown ang kaya ng calculator nyo? Have you been playing with your calculator? For my calculator, which is a cheap calculator, I can solve up to 4 equations in 4 unknowns. So pag may problem kayo, just use your calculator basta hanggang 4 na unknown. If you have more than 4 unknowns, sorry ka na lang, you'll have to do some mathematical manipulation, paper and pencil mathematical manipulation. Let's do an actual example. For the circuit shown, solve for the values of I1, I2, I3, I4, I5, and Ix. Okay. In this particular example, I have a current-controlled current source. But that doesn't make the problem any more difficult, even if it is a current-controlled current source. The value of this current source depends on the current flowing through your 30 ohm resistor Ix. Kung ano man yung current dito, the value of this current source will be 4 times of that current Ix. Okay, I have 6 unknowns. I need 6 equations. How many equations can I form using KCL? Can I have your answer? How many equations can I form using KCL? No answer? How many essential nodes do I have? Okay, so somebody answered already. David Gan, no? 3. 3 is correct, no? I have 4 essential nodes. I already labeled that. My essential nodes are A, B, C, and D. I have 4 essential nodes. I can form 4 minus 1 or 3 KCL equations. So I have 6 unknowns. I can form 3 KCL equations. No? What are those KCL equations? For node A, okay, minus 8, dahil papasok yung 8, palabas yung I1 plus I1, palabas yung I2 plus I2, palabas yung 4ix, so plus 4ix is equal to 0. That's for node A. For node B, papasok yung I2, so negative I2, palabas yung I3 plus I3, palabas yung IX plus IX, that's equal to 0. And finally, for node C, okay, papasok yung I3, palabas yung I5, palabas yung I4, papasok yung 4IX. That's equal to 0. Common mistakes, usually common mistake ng mga estudyante, may branch na nakakalimutan sila. They forget a branch. If you are doing KCL on a node, you should have equal number of current terms as the number of elements connected to this particular node. No? So in this particular node, you have 4 elements connected. You should have 4 current terms. Very common mistake. Pag minsan, oops, nakalimutan yung controlled source. Ano? Dahil lang gagaling sa taas, nakalimutan na kasama pala yun. So that's very common mistake. So 3 KCL equations. In this particular case, itong node T, this is what I assigned to be my reference. That's why I didn't form a KCL equation for it anymore. Like I said earlier, if you combine these 3 KCL equations, eliminate the proper currents, you're going to get the KCL equation for node D. So how many unknowns do I have? 6. I have 3 equations. I need 3 more equations. So the remaining 3 equations can be formed by applying KVL to the meshes shown. How many meshes are there in this particular circuit? We have 5. 1, 2, 3, 4, and 5. No? This is also a mesh. Bakit hindi ko pinili ito? Why did I not choose to apply KVL here? Because I do not know, what don't I know? I do not know the value of the voltage across my 8 ampere source. No? Hindi ko alam kung ano yung voltage dito. There's a voltage here. This is V 8 amperes. I don't know this. So if I apply KVL here, I'm introducing a new unknown. I don't want to do that. Same thing here. If I apply KVL here, I'm going to be introducing a new unknown. Samantalang dito sa 1, sa 2, at saka sa 3, applying KVL here, I will not be introducing any new unknowns. Okay? So, mesh 1, okay, I'm going from minus to plus in polarity, so it's negative, so that's negative 10 I1. I'm going from plus to minus, so that's 20 I2. I'm going from plus to minus, so that's 30 IX is equal to 0. Mesh 2, let's start with the 40. I'm going from plus to minus, so that's 40 I3 plus to minus 60 I4, and then minus to plus 30 IX is equal to 0. And finally, dito sa mesh 3, okay, you have 60 I4, negative 50 I5, and then 10 is equal to 0. 6 equations in 6 unknowns. So here are your KCL equations. Here are your KVL equations. Like I said, hindi na sakop ng course na to na turuan kayo mag-solve ng simultaneous equations. Dapat nakuha na nyo yan. Unfortunately, in this case, hindi kaya ng calculator. I cheated. I used MATLAB, and I got these answers. You can check these answers out by using whatever tool you want in your computer, or Octave, MATLAB, or whatever online matrix calculation techniques that you know, whatever. Are there any questions? Any questions so far? So this is just what I tried to do was I just tried to put some structure in solving for the unknowns in a particular circuit. This is the case where you have a lot of unknowns in your circuit. You don't want just to form any KCL or KVL equation, because actually you could have. If I didn't teach you what I just taught you now, looking at this circuit, pwede nyo i-brute force, ano? Basta't lahat ng KVL equations na pwede nyo i-form nyo, lahat ng KCL equations na pwede nyo i-form nyo, and then bahala na si Batman, ano? You just solve all of this simultaneously, and you might be able to come up with the correct answer. No? You could have used brute force. But here we put a little bit of structure. So again, any questions with regard to this method? So there's a question. Sorry. Question from Peter, no? Pwede po bang pa-drawing ng simple essential branch? Simple essential branch. I don't. These are all essential branches. No? These are all essential branches. I don't think there's such a thing as a complex essential branch. No? Basta ang definition ng essential branch is an essential branch is a path that connects two essential nodes. Right? So this is an essential branch because it connects A and C, no? And both A and C are essential nodes. Okay. If I had put a resistor here, that is still this whole thing is still an essential branch. Because this is only one path. This is only one path that is connecting this essential node and this essential node, no? Remember the definition of an essential branch is it connects two essential nodes without passing through any essential node. For example, this is not an essential branch, itong dalawang resistors na to. While it connects A and C, which are both essential node, it is passing through B, which is also an essential node. So this is not an essential branch. I don't know if I was able to answer your question. Okay. Okay. Any other questions?
Sir, hello po.
Yes,
what do you mean po by independent tsaka dependent equations?
Kasi pag sinabi mong independent equations, no, ibig sabihin when I have a set of equations, let me write it out na lang, no, mathematically. Let's say I have a set of equations. A1x1 plus A2x2 plus A3x3, let's say is equal to 0. No? Let's say x1, x2, and x3 are my unknowns. Unknown, no? So A1x1 plus A2x2 plus A3x3 is equal to 0. No? Then let's say I have another equation, B1x1 plus B2x2 plus B3x3 is equal to 0. Okay, then let's say I have a third equation, C1x1 plus C2x2 plus C3x3 is equal to 0. When do we say this is dependent? These are independent. These are independent if none of the equations can be derived from the other two. Maybe I'll give you a very, very simple example. No, let's say 5x1 plus 6x2 plus 7x3 is equal to 0. Let's say that's one equation. No, and then my second equation is x1 plus x2 plus x3 is equal to 0. And let's say my third equation is 6x1 plus 7x2 plus 8x3 is equal to 0. Can I use this? Can I use these three equations to can I solve for x1, x2 and x3? Yun yung question dito. Can I solve for x1, x2 and 3? The answer is no.
Yes, I know.
No. Bakit? Ang inclination mo, sabihin mo yes, ano? Because I have three equations and three unknowns. But actually, if I add these two, I'm going to get the third. Nakita nyo? Pag in-add ko yung 1 at saka 2, okay, 5x1 plus x1, that's 6x1, 6x2 plus x2, that's 7x2. No? If I add 1 and 2, I'm going to get the third. Meaning to say, this is not independent. Not independent of the first two. So kung subukan mong ipasok to sa calculator nyo at isolve, lalabas, sasabihin ng calculator nyo, you don't have a set of dependent equations, of independent equations. Yung first two equations mo are independent, but the third is not independent of the first two. Okay, because if I add equation 1 to equation 2, I'm going to get equation 3. Na kuha mo na yon.
Thank you po, sir, for the clarification.
Yeah, no, did you understand?
Apo, sir.
I hope you understood.
Apo.
Ano? Ngayon, if my third equation were completely random, di ba? Kung yung third equation ko was completely random, was independent of the first and second equation, I can solve for x1, x2, x3. But in this case, my third equation is not random. I can just simple na lang, no? Very, very simple. X1 plus x2 is equal to 0. Okay? 2x1 plus 2x2 is equal to 0. Can I solve for x1 and x2?
No po.
Diba?
No po.
Why?
Kasi two times the first equation lang.
I just multiplied the first equation by 2 to get the second equation. So these are not a set of independent equations. Right? Because the second equation can be derived from the first equation. So they're not a set of independent equations. So obviously I cannot solve for x1, x2. So whenever you form whenever you form a set of equations to solve a problem, you have to make sure that the equations that you form are independent. That is the trick. If you don't form a set of independent equations, paikot-ikot kayo sa solution ninyo, wala kayong makakuhang sagot. Okay? Now, what I'm saying here is, if I apply KCL to 3 out of my 4 nodes, sigurado ako, basta KCL to 3 out of the 4 nodes, sigurado ako that those will be independent. And if I apply KVL to my meshes, sigurado ako those will be independent. No, take my word for it na lang muna. No? Now, if you do that, for sure it will be independent. Okay? Any other questions? Okay. Ang next topic natin, I'll just give a very short introduction. Kasi sa previous problem, we still had to solve 6 equations in 6 unknowns, no? I don't know if you'll be happy solving 6 equations in 6 unknowns. And that circuit is still a relatively simple circuit. No? So, ang target natin, pasimplehan pa, mas pasimplehan pa, no? So, hindi ba pwedeng mas konting equations ang isosolve? And that is the subject of nodal analysis. Actually, there are 2 techniques that are used in electrical engineering for simplifying circuit analysis further. One is nodal analysis and the other one is mesh analysis. In nodal analysis, you apply KCL to the nodes. In mesh analysis, you apply KVL to the meshes. But ito, you'll take this up in the future, in your future courses. Ang kukunin sa 1, 2, 3, ito lang muna, itong nodal analysis. Because most of the problems that you will encounter in EEE at this point, pwede namang isolve using nodal analysis. Okay, ano yung basis for nodal analysis? Well, anyway, typically, nodal analysis, the number of simultaneous equations needed would be equal to the number of essential nodes minus 1. In other words, if I have 4 essential nodes in my circuit, I will only have to solve 3 simultaneous equations and not 6 like the previous example. The method is based on the fact that if you know all the node voltages in the circuit, you can solve for any branch voltage. That is the basis for the method. I'll just give an example. So let's say I have this circuit. Let's say this is A, this is B, this is C, and then this is my reference. Okay. If I know the node voltages, if I know VA, and I know VB, and I know VC, okay, then I can solve for, let's say this is R1, no? And this is R2, and this is R3. I can solve for VR1. If I assume that VR1 has this polarity, what is VR1? VR1 is VA minus VB. Okay, if this is VR2, I can solve for VR2, which is VB minus VC. And VR3 is just equal to VB. If I know VR1, VR2, VR3, then alam ko na rin yung I1, alam ko na rin yung I2, and alam ko na rin yung I3. So I1 is just VA minus VB over R1. I2 is VB minus VC over R2. And I3 is just VB over R3. So ang key dito is, ito lang ang kailangan kong malaman, VA, VB, and VC. Pag alam ko yung VA, VB, VC, masosolve ko na for all of the currents that I need to solve for. So that is the trick in nodal analysis. No? And then I have a general procedure here, but we're going to take this up in the next meeting. Okay, so are there any questions from anyone?
Sir, tanong ko lang po is, pwedeng makuha yung mga slides. Down po kasi ulit. So, hindi ko po na-download yung per week.
Sige, what I'll do, no? Since hindi nyo ma-download, let me stop sharing. Since hindi nyo ma-download because Uble is down, I'm going to send a link to the lecture slides.
Thank you.
Okay. Any other questions? Okay, so again, don't worry, Uble is down. As soon as Uble is back up, we will announce when the new deadline for the quiz 1 is. Unfortunately, hindi mapasok yung quiz 2 because Uvle is down. But there will be a quiz 2 for week 2. There will be a quiz for every week. And then I'm also going to be releasing a problem set for week 2 very soon. Okay. The problem set, I hope you didn't have any problem with it. Actually, it's quite straightforward. No? Wala namang trick dun eh. The solution is very straightforward. Okay, so that's all for today. No? See you again next week. Thank you.